Hi, this is webassign problem 1B from the limiting reactant and percent yield webassign. This problem is a limiting reactant problem, and in my problem it said that there were 5.08 grams of CaC2 and 5.08 grams of water. And you can tell it's a limiting reactant problem when you are given the amounts of both reactants. Maybe you have more than one reactant like in the problem before, but if you're given the amounts of all the things on the left-hand side, it's a limiting reactant problem, and you have to find out which one, maybe this one or that one, is going to be completely used up and which one there's going to be left over. So which one is the limiting and which one is the excess. And there's many ways to do this, but the way we'll do it today is we will take the amount of water and do stoichiometry from this one to one of them on the other side, and the one I chose was the C2H2. I chose that one because it was actually easier to add up the molar mass. So we'll do a line of stoich from the water to that one, and then we'll do a line of stoich from the CaC2 to that one also. And in fact, I will start with the CaC2 first. And we will get rid of... So we will start with the 5.08 grams of the CaC2, and I'm not going to have enough room, so I'm going to have to leave out some of the labeling. Change it into moles. So 1 mole of CaC2 has 64.1 grams. I added up 1 Ca and 2 Cs to get the 64.1. Now we do the mole ratio, and in order to do that we have to we have to balance the equation, and I forgot to do that first. So we'll go back and balance the equation. I believe there's a 2 in front of that water right there, and the rest of them are 1. So there's 1 Ca for 1 C2H2. So again, I got those numbers from, there's a 1 in front of there, so I put that one there, and there's a 1 in front of that one, I put it there. This is the one I'm given, and this is the one I'm trying to find. So given, the one I'm trying to find. And now the last part is I change it into grams. So 1 mole of the C2H2 stuff, I write C2H2 just to remind me I need to add up the molar mass. And that one we're going to call 26.036 grams. And we do the math, and we're going to get a number, and that number is 2.06 grams of the C2H2. And again, to do that math, I did 5.08 divided by 64.1 times 1 divided by 1 times 26.03, and I got that. Now we're going to move on to the stoichiometry from the water to that one. And again, I just chose that one because it looked like the molar mass was easier to add up. So we'll do 5.08 grams of water, and we'll change that to moles. So 1 mole of that has 18.02 grams. And we'll do the mole ratio. That looks like there's 2 waters for 1 C2H2. The beautiful thing about this is that we really just repeat and grab some numbers. I get to grab that number and use it again. So 1 mole of the C2H2 stuff, I added it up already, is 26.036 grams. I do my math, 5.08 divided by 18.02 divided by 2 times 1. I really could care less about the 1, times 26.036. And after all that math, I get 3.67 grams of C2H2. Now, neither of these really are our answer, because that's not what we're looking for. We're looking to see which one produced the least. This is the smaller number, so we go way back to the beginning, and we go, aha, the CaC2 actually produced the smallest amount, so the CaC2 must run out first. The water produced the most, so that one must be the limiting reactant. And in fact, we can see that when we look at the answers. It said the limiting reactant was CaC2, which is that one, and it said the excess reagent was the water, which is that one. So we're going to have leftover water. Now we have to figure out how to find how much water is left over. So if CaC2 is the one that is the limiting reactant, you're going to have 0 grams left over. That's why that answer 0 is there. To find the remaining mass of water, we have to do stoichiometry from the limiting reactant to the limiting reactant. So we're going to do stoich from the limiting reactant to the excess reactant. And let's do that to begin with. So again, we'll start with 5.08 grams of the CaC2 because that's what was given in the problem. And I'm just going to copy some stuff I had before. So 1 mole of that is 64.1 grams. We're going to do the mole ratio. There's 1 CaC2 for 2 moles of water. And we got to change those moles of water into grams. So 1 mole of water is 18.02 grams. And we do 5.08 divided by 64.1 times 2 times 18.02, and we get 2.856. I know that's way more sig figs, but I did it because we're going to subtract out here, and I wanted to make sure I had enough digits. So that is water, and that is how much we actually used or needed to react in proportion to the CaC2 we had. So that's not our final answer yet, because you can tell, look at our answers right there. Now, how do we get that answer? We are going to take what we were given, and we're going to subtract out what we used. So the given is given in the problem, hence it's called the given. And that was 5.08 grams of water was given in the problem. And how much did we use? That was from the last calculation we just did, which was 2.856 grams. So notice this number always has to be bigger than that number. We subtract those two numbers and we get 2.22 grams left over. And that's what that amount is right there. So that's how much water we have left over. And a lot of times when you do a reaction, you have excess of one of them because it makes the reaction go better, faster, or goes to completion. If you put them in the exact proportion, sometimes the reaction doesn't go to completion. I hope this helped you a little bit with doing your stoichiometry homework.